On number 15, we're still following the same directions as 13 and 14, where it asks us to find the volume of the 3D solid and to leave our answers in terms of pi if necessary. Remember, that's necessary every time you have a circle involved. So since we have some circles involved in this figure, we'll definitely have a pi in our answer. Number 15 is what we call a composite solid. And for composite solids, you'll either be using addition or subtraction as part of your process. Either you have two solids, one on top of the other or attached in some way, that would be addition. And sometimes you have one solid being removed from another, and that's when you use subtraction. Well, in our case, we have a cylinder in the inside of another cylinder, and so that is going to be a subtraction problem. This inside cylinder is being removed from the larger cylinder. So we're going to be using subtraction. So we're going to have to find the volume of the large cylinder and subtract the volume of the smaller cylinder from that. So just like in number 13, we talked about how to find the volume of a cylinder. It's always the area of the base, which is a circle, pi r squared, times the height. Now, just as a side note, remember the height doesn't have to be vertical in a cylinder. We could turn this cylinder on its side, and the bases would be on the sides, and your height would be horizontal then. It's always the distance between the two bases. So in this case, it's vertical. We'll have to look at the radius and the height of both our large cylinder and our small cylinder. So on the large cylinder, the radius is going to be from the center here all the way to the edge. So this is what we're looking for the radius of the large. We're given from here to here is 2 meters, and from here to here is 2.5 meters, which means all the way across for this radius, we're going to add the 2 and the 2.5 to get 4.5 meters as the radius of my large cylinder. The height is this distance between the two bases, which is 9 millimeters, and that's the same for both cylinders. So now all we need is the radius of the small cylinder, which we were given. That's this distance here, which is 2 meters. So now that we've identified everything, we're ready to find the volumes of each and subtract to find our volume of the composite. So we would have pi times our radius squared times our height minus our pi times our radius squared times our height. So remember, our answers are in terms of pi, so we're only doing this part of the calculations in our calculator. So we would do the 4.5 squared times 9 and find that the volume of the large cylinder is 182.25 pi, and then subtract, do the 2 squared times 9 in your calculator and get 36 pi for the volume of the small cylinder. So now we need to subtract, and those are like terms, they both have a pi, so we know our answer will have a pi. We just need to do the 182.25 minus 36 in our calculator to get 146.25. So 146.25, don't forget your units. Since we were meters and linear measurements, we're going to have cubic meters for our volume. So the volume of the composite solid is 146.25 pi, don't leave that out, cubic meters.